Okay, cool. So this is part 2 for assignment 3 with hydrostatic pressures on the vessel. So the first thing we're going to do is we're going to pull the static structural up here, and we're going to right click on geometry and import geometry and choose the one that you downloaded. You'll probably find it in browse. So we choose that, and then we double click to open space claim, or you can right click and say edit in space claim. Okay, cool. So now that we are in space claim, we're going to go, we've got the tree here. You click the arrow to pull it down. What we're going to do is you go to vessel, you right click, detach all, right click, detach all on these two mid surfaces. Then you can close the vessel, and now with all three of these objects here, we're going to go to share topology and select share, share, and share. And that's all that we have to do in space claim, and it should save automatically, so you can just close here. Cool. So now that we're back in workbench, we're going to go to mechanical, so you can say right click edit, or you can double click, and now it'll show that it's starting mechanical. Cool. So now that we've opened mechanical, we see that the geometry has a question mark here, which means we need to assign thicknesses to support 1, support 2, and vessel. So I'm going to click here and hold shift to select all of them, and I'm going to make it 10, which was specified, 10 millimeters. Do it with support 2, shift, 10 millimeters, and the vessel, shift, oopsie, 10 millimeters. So now that is all green ticks, which is what we want. Next thing to do is we go to connections, you right click and you say insert manual contact region. Now we're going to have to do a contact and a target. Our contact, make sure you're on surface face select and single select. It should just generally be on that, but just make sure you are, and that will allow you to select that. Then we're going to say apply, and that's our contact. Then our target is going to be this object here, and notice that it gives us the surfaces here. So now we're going to change this to make sure that they're touching. So the contact shell face is already correct here, but we're gonna choose it as top anyway instead of program controlled. And now this one, we don't want the blue under here, we want it on the inside, so we say bottom. If in another situation it doesn't give you, you can just obviously just play with it and see which surface it gives you. That's why it highlights it here, which is quite nice. Then you'll notice here type, it says bonded. Bonded is for welding, which is right for now. In the next one where we need friction, we need to use no separation. So leave it on bonded. Then we're going to go and make another manual contact region, and we are now going to select this time that surface. Apply, target, that surface, apply. Then we're going to choose these again as top and bottom, and that shows us we have the right situation going on there, and it's bonded, which is perfect. Next we go to mesh, and you're going to say insert sizing, select the geometry for the mesh. We want to make the whole thing, so we're going to go here to box select, and we're going to choose the entire body and apply, and it should be 48 faces, which is perfect. Then we're going to go to element size and get it down to 50. 50 is the lowest number that we could get right on the student edition. Cool, so that is sorted. Okay, then we go and we say generate mesh. Cool, so now the meshing is done, as you can see. Okay, so the next step after making the mesh is we're going to go to static structural, and we're going to insert a fixed support, which we're going to choose the bottom here. We're still on box select, so we're going to go back to single select and face, and we're going to choose these 6, oopsie, these 6 here, and these 6 here, and 12 faces, so that's perfect. Then we go to static structural, insert hydrostatic pressure. So now this is going to give us that cool little color chart. With fluid density, it's currently on kilograms per millimeter cubed. So to make that easier, we just go to units quickly, and we go to the top one, and that gives it to us in kilograms per meters cubed, which is then 1,000 for water. And then we go to hydrostatic acceleration. We change it from a vector to components, and in the y direction we're going to give it 9,81. And I think this is where if you put points instead of comma, it doesn't want to read it. So if you have a problem with that, use a comma instead of a point. The direction also doesn't matter for this one. I'm not 100% sure why, but I know it doesn't. Y coordinate is 0.71, or actually comma 71 if it doesn't read, and the reason for that is that's the diameter of the vessel. Okay, cool. Then geometry, we're going to select the one that you want to put the hydrostatic pressure on. So you're going to hold control and select all 4 of these guys, and you'll say apply. Then the hydrostatic is sorted, and you get this cool rainbow chart thing. Then we're going to go to insert, and we're going to say pressure. We're going to choose the geometry again to be all 4 of these. You want the arrow to be pointing from the inside to the outside of this object. So this has to be 1 megapascal. Okay, so let's go back to units and change it to metric and make it 1 megapascal. So now if we see that the arrow is pointing in from the out to the inward, so then we're going to make this -1. Cool, so now it's pointing from inside to outside, which is what we want. Cool. Then next we go to solution. We click the solution and we say beam selection results, and you change that to a yes. Then we go to solution, insert, deformation, total deformation, solution, insert stress, von Mises stress, and that should be all. Okay, I did forget something. Go to static structural, and we've got to actually insert standard earth gravity, and then you choose the direction. You can see that the y up, so we're going to choose the negative y direction for our static earth gravity, and we've inserted total deformation and equivalent stress, and then we just solve this. Okay, so now that it's solved, we can see a green tick on total deformation and equivalent stress. For the assignment, we are looking at equivalent stress, so you can see this thing is ugly. Well, how he wants it is you go to scale up here on the left, and you say true scale. You can take the mesh off with no wireframe. This is how he's got it in the pictures in the document. And then lastly, you click the scale here and you get a plus and a minus. And if you zoom in, if you zoom out, if you make negatives, it'll give you similar to what his looks like. So all you do is you go plus and minus, and that'll change the scale. Cool. And that is all for equivalent stress for hydrostatic pressure. Then we are going to do the exact same thing, but with contacts that are not bonded. So what we do is, instead of redoing this entire thing, we're going to go back to Workbench, which is here, and we're going to right click somewhere here, and we're going to say duplicate, and this should take a few minutes. Okay, so now that it's duplicated it, we're going to double click model and open mechanical. Okay, now that we have mechanical open, we're going to go back to those connections that we had, open the contacts and click bonded. Now we're going to change the two bondeds to no separation, bonded to type no separation, and solve. Okay, now that it's solved, we're going to see that the total deformation and equivalent stress is again green ticks. Click the equivalent stress, and here's our results. This has already been changed to no wire and true scale. Then you can come here and you can change it if you like. I'm pretty sure this is very similar to what he's got in the pictures that he uploaded on the assignment. So that's about where you want to be. If try and get it so that it looks as close to what he's got as possible. And that's all that you do. That's basically all the steps to do the second part of assignment 3. Sweet, hope that helps.